Alright, boys and girls, welcome back for the drive-through for a 3-mix. Gosh, I'm just screwing this video up 100 different ways. If you have not already done so, I want you to go and watch this video here. Click that link. I would just play it during my video, but I think it would be a copyright violation on YouTube. But it's going to be look, it's 43 seconds. It's really short, and it kind of gets to the idea of what I'm trying to help you visualize here. Okay? But chapter 10, welcome, conic sections. What the heck does that mean? It means parts of a cone, or actually cones. So let me show you the foundation here. Imagine you have a cone. A cone is made up of a circle and some lines, and then we copy it down here. Okay? So imagine that cone. And then a conic section is what happens when you slice that cone. So like, let's say we sliced it, okay, with a plane, so it's like a flat surface. So we sliced right through the cone, and it would create something that looked like this. Okay, and those look like ellipses, but if we looked at that plane from the top, it would actually be a circle, just like that's a circle. Okay, so what are the conic sections? Well, you just found out the first one. One is a circle. Okay, and you know what a circle is. It's a set of points in equal distance from the center, and the distance that they are from the center is called a radii. The second conic section is called an ellipse. Okay, an ellipse, well, actually a circle is a type of ellipse. An ellipse is kind of like a circle that's been squashed. What an ellipse actually is like if you wrapped a string that was closed, like a loop, around 2 points called foci. Well, that's not what it would look like. And then you took that string and you pulled it as tight as you could as a loop instead of a string. You took that loop and pulled it. And we'll get into that more. Okay? The other two conic sections, again, one of them you definitely know about, and that would be a parabola. And a parabola is a U-shaped figure made from an equation involving y equals x squared, or you could have parabolas that look like this. And that's x equals y squared. Okay, and then this one is new. It's called a hyperbola. And it's not hyperbole, and it's not hype beast. It's kind of like a parabola, but it's a little bit more open. Maybe you've heard of hyperbolic lenses. Those are high-end lenses used in cameras and especially in like satellite dishes. I think because like the thing about a hyperbola is every single ray of light or beam gets bounced to the same point no matter where it hits. And so that's why satellite dishes are in that shape, because here would be like where the information is grabbed. Fun fact. Okay. Oh, I need to erase this. This is what I messed up in the last video. Okay, so take a look at number 1 here. Now I want you to just watch what I'm doing. You can follow along if you want, but I'm not going to. This would be really hard for you to do without help. And the help that we're going to use is called Desmos. And it looks like this. Hopefully you've been to Desmos before, but it's going to do all of our graphing for us. And you might be wondering, well, I want to use my graphing calculator. Well, I want you to come see me. I can show you how to use a graphing calculator, but I've had the graphing calculator software stripped from me, and it's hard to get back because Texas Instruments is a total racket. Have you ever noticed that they're the only people that make the graphing calculator? There's a reason for that. You should look into it. I know Casio makes one, but there's a reason no one uses anything but Texas Instruments. But anyway, I digress. How would I figure out what the graph of that is without understanding things about this chapter? Well, I'd have to guess and check points. Well, that's pretty hard. So what if I did this? What if I solved it for y squared? 4y squared is 36 minus 9x squared divided by 4. And you get y squared is 9 minus 9/4 x squared. Square root both sides, and you get y is, okay, let's see, I guess that is not 3 minus 3/2 x squared. It's just plus or minus the square root of 9 minus 9/4 x squared. So you'd have to put two equations into your graphing calculator to figure out how to graph this in your graphing calculator. Because your graphing calculator only takes things in y equals form. Okay? But what would happen if we put in a 2 for our x? Well, you get 2 squared is 4. 9 divided by 4 times 4 is 9. 9 minus 9 is 0. Nice. What if I put in a negative 2? Well, I get the same thing because negative 2 squared is the same thing as positive 2 squared. So let's let each one of these be worth half. So this is 1, 2, 3, 4, and this is 1, 2, 3, 4. Okay, so 2 comma 0 would be here. Negative 2 comma 0 would be here. Well, what if I put in, let's say, like a 1? All right, well, 1 squared is 1. 9 minus 9/4 is like, let's see, what is 36/4 minus 9/4? 27/4. And 27/4 is 6.75. So if I put in a 1, I get, no, square root of 6.75. I'm going to screw it up again. So that's like, I don't know, like a little bit, it's like 2.7 or negative 2.7 because it's plus or minus. So just bear with me here. This is not how you're going to do it. It would be, sorry, right around there. Or it could be right around there. Okay? If I put in a negative 1, I'll get the same thing. I genuinely hate this. Okay, well, what value would I put in if I get a 0, if I put in a 0 for x? Well, 9 minus 0 is 0, I get a 3. Okay, or if I put in a 0, I could also get a negative 3. Alright, so that would be here and here, and now I have an idea. This is going to look like an ellipse. Now, you would have no idea about that. So here's where Desmos comes into play. I want you to play around with Desmos for this chapter. So, we're going to type in, make sure I get this right. I got to click back and forth a little bit. 9x squared plus 4y squared equals 36. Alright, there's a better version, a cleaner version of what I had. Okay? So we're going to use Desmos. And that'll help us understand what these graphs would look like a lot quicker. I encourage you to do Desmos for number 2. Let's look at number 3, 8y, 8x, 40. 8x squared plus 8y squared is 40. Oh, a circle. So these numbers in front of the letters mean something. Got it. Got it. Okay? So that's how you're going to do these. Now, let's move on to the next page. Identify the center and the intercepts of each conic section. Okay? Give the domain and range. So, let's just make a chart. We've got center, intercepts, domain, range, number 4, 5, and 6. You guys can do the rest. So the center of 4 is 0, 0. That's the dead center of the conic. It looks like the intercepts are plus or minus 3, 0, and 0 plus or minus 3. Okay, you can write out four different points if you wanted. I'm just saving time. The domain, well, x looks like it goes from -3 to +3, and the range, put it in the range column, you idiot. The range looks like it goes from -3 to +3. So hopefully you understand what you're doing now. Okay? The range, the center here is 0, 0. Okay? The y-intercept looks like 1.5, 0, and 0, 1.5. There is no x-intercepts. X, how about this? Let's just switch up to interval notation here. X goes from -infinity to 1.5 and from 1.5, that's a -1.5, to infinity. Y can be anything. And again, I know that you're going to have some confusion about this, so come see me. This is getting a little bit tougher. 0, 0 is my center. Looks like my zeros are at plus or minus 1, plus or minus 1, 0, and 0, plus or minus 3. My domain, x can be anything between -1 and +1, and y can go from -3 to +3. Okay? Alright, now let's use Desmos to do all of this. Let's see, I'll do 10, 11, and 12. So we can see all three of those on the graph. Okay? So, I'm going to go to desmos.com, x squared plus (9y squared) equals 9. Okay, good. Looks like a conic section to me. Let's do the next one. X squared plus y squared equals 25. That's that one. Okay. And finally, 9x squared plus y squared equals 9. Oh, look, we've got some cool shapes developing here. So that's how you're going to do these. Just put them all down and match them. And that's enough to get you started with this chapter. It's a long enough video. It's my third try. It's the end of the day, and Brendan's ready to go. Boom!